got another old vintage radio. This is the 5-tube GE model that goes back to, I want to say, the late 30s, maybe early 1940s. I don't have any data on this one. I spent like hours today trying to find a schematic, and I could not find the exact schematic. But we're going to see if we can get this one working, because this one has a few things wrong with it, as you will see. This one's quite a rare beast. Check this out. Check out this old beast. This would be, I think, late 30s, maybe early 40s General Electric radio. I just got this. This is my radio, and we're going to do a restoration on it and see if we can get this thing going. Now, the wiring is all shot on this, so I'm probably going to have to do a lot of restoration because the insulation is just falling off these wires. First things first, I'm going to figure out what the chassis is and get myself a schematic for it. So let's turn around and get the chassis pulled. Actually, I guess before I do that, I got to remove the knobs from the front here, which just pop off. It should just pop off. Try to do this without damaging the wood at all. There we go. Okay. Now I should be able to remove the screws and remove the chassis from the cabinet. Here's a look in the back of this old beast. I noticed that one of the tubes was just lying inside here. I've got all the tubes for it. I don't know if they're any good or not. Hopefully they are. Some of these ones might be kind of hard to try and find now because they're very old, but hopefully the tubes themselves are okay, and it's just going to be the standard issue capacitors and stuff and resistors maybe that have gone out of value. Anyway, couple screws hold the chassis, and let's pull the chassis. And to give you an idea here, here's the warning sticker that was on all the old radios. See, at one point in time you actually had to have a license from Transport Canada. Warning, any person installing or operating this receiving set without first obtaining a license from the Minister of Transport of Canada is liable on summary conviction to a fine not exceeding $25, and the said receiving set may be fortified. To His Majesty, in order of the Minister for such disposition that the Minister may direct. His Majesty. So this would have been under probably King George. And see, it's an extraction from the Radio Telegraph Act of 1938. So this is going to be obviously after 1938, this radio, but I guarantee you this is pre-war. This is pre-war. So probably 39 to 40, 44, 43, somewhere in there is when this set would have been made. A couple 1/4-inch screws hold the chassis in place. And now the entire unit should just lift out. Three more. Oh, should be no more screws. It should just lift right out. And it does. It's just being stubborn. Okay, so there's the radio. We'll just place the box out of the way. And of course the tube that was stuffed down the side, I'm sure goes right in here, complete with dead spiders. But that looks like that's where that tube there goes. Just like that. So this is a 5-tube radio. I'm going to see if I can find any schematic circuit diagrams for this one, and then we'll get working on restoring this chassis. We'll just tip it over so you can see the bottom of it and what we're going to have to do. These are pretty simple, so there's going to be some capacitors that definitely need to be done on here, and more than likely that's all that's going to need to be done. Hopefully that's all that's going to need to be done on here. Let's take a look at the actual wiring on the bottom. Still got a couple wax capacitors here that's going to have to be changed out. Some of these ones here. And we'll check out this wiring. This power cord definitely has to be changed out. But say first things, I'm going to see whether I can find any service data on this. I always like to have, when I'm dealing with something vintage like this, I always like to have a schematic handy. First of all, to make sure the tubes are in the right place, because you never know. The last person that had this thing could have started switching tubes around. So that last radio that I had, that's mine, the Rogers from the 1920s or early 30s, the 4-tube job that I had, spent a lot of time trying to figure out why I had no volume after changing all the caps and replacing some of the burnt wiring and so forth, only to find that 2 of the tubes had been swapped before I got it. So always good to have a diagram handy. Let's dust it off first. This looks to be a GE418. So that's where we start. We'll start looking for a GE418 sub 1. Well, I'm not able to find a schematic at this particular moment in time. I'm still looking for one, but I think before I even bother with the schematic, we're going to change out the caps in here and see if we get any sound out of this thing. So the first thing I'm going to do is I'm going to change out this ugly power cord. It's got to go. So we'll just cut it off. It just goes between the power switch and the transformer. So we'll just cut that there and get rid of this disgusting, deadly power cord. And that has to go. Got a more modern one here. Yeah, it doesn't look quite as nice, but it'll do the job. Okay, I got this drain relief on the correct way so that it'll fit through here. See, one side's bigger than the other. So I should be able to pop it through here now and lock it in place. There we go. This drain relief is now in place, and I can go ahead and reconnect the power cord. And unlike the previous installation, I'm not going to just use a tape to wrap it. I'll put some heat shrink tubing on for the power transformer here. The original one, they just used this cloth type electrical tape, which is a fire hazard waiting to happen. Not that this radio, when I get it going, and I say when because I'm sure I will get this thing going, is going to be put into service. I don't run any of these old dinosaurs. I just fix them for the challenge of fixing them and to increase their value, because a vintage radio that's working has a little more value than one that's not working. There's the old connection point there. It was soldered on, so we'll just redo that, put some heat shrink tubing on it, and then reconnect the other side to the switch. I'm going to change out the capacitors and see whether that'll make this old beast give me some sound. Looks like we've got a 5x5 at 450 and a 20 by 25 on this. So this is a 3-stage capacitor, 2 for high voltage and 1 for low voltage. There's the 3 wires here. I'm gonna guess that the green is probably the low voltage wire and the other 2 are the high voltage wires. But we'll just replace this with 3 electrolytics that will replace it. They're all got a common ground on them. So I'll just use 3 electrolytic caps to replace that. That racket you guys hear in the background is indeed the electric furnace that is now running, as it's getting pretty chilly outside right now this time of year. Okay, that's got the power cord repaired. Let's dig into these caps. It looks like there's 1, 2, 3, 4, 5 of these paper jobs that have to go out on this thing, and then we'll try to see if it powers up. So let me go grab my old high voltage, I'm using Mylar type caps to replace on this unit. So first we'll start down on this one here. We'll just clip this one out. See what value this one is. .400 looks like .05. Yeah, 0.05 at 400 volts, so probably a 0.047 will be close enough. Let's see what I can find here. A new component through the hole in the socket there. Oops, have to redo that because I didn't let it cool. Let's clip the old one out of here first, the old pieces. Okay, there's that one in place. These black ones should probably also be changed out, but I don't know if we're going to have the right values for those today. We'll do these paper ones first for starters. This is a 0.1. Looks like this transformer's been changed at one time. This is not the original transformer that's in here. It's only bolted in with one bolt for one, but the wires have all been cut and spliced in. Somebody has changed this transformer at some point on this radio. It'd be interesting to see whether it actually works when I change out these caps, and I might even try firing it up before I change out this electrolytic. I just want to get the bypass caps taken care of right now, see whether the unit will actually do anything. There's another one up here. There's two more of them up here that need to be changed. One thing neat about working on these old radios, like that's not even soldered in, is you never know what you're going to get, right? When you work on these old beasts. That one, like the solder wasn't even on. It goes to that point right there, and it wasn't even like it before I even cut it, or I didn't even get a chance to cut it. It actually just broke. This one here is something that's noteworthy is when you're dealing with old electronics like this, if there's any oil-filled capacitors, it's pretty much guaranteed that they're going to contain PCBs. So, no opening up old capacitors. These wax paper ones shouldn't have any PCBs in them. Look at this insulation's coming off this wire. Yum. So I say, the wires get really brittle in these old units, and they tend to fail. So you gotta be careful. I should probably replace all the wires that are in this unit, and I probably will do that at some point if I can get the radio actually working. The first line of business is to see if I can get this thing to make any sound, and then we'll deal with everything else that needs to be done on this thing. As I've said a few times, an old radio like this is not something that you can put into service and use it every day. This is one of these ones that you fix it just because it's an antique and it goes basically up on display, but there's no point in having it if it doesn't work. So we change the parts that we need, that we know are bad and have to be changed to get the unit operational, and then we'll deal with the rest of it at that point. Same with the cabinet. If I can get this thing operating properly, then I'll make the effort to get the cabinet taken care of too. Okay, the moment of truth. Let's see whether it's going to do anything. I'm going to plug it into my my light bulb current restrictor, so that if something is bad, it's not going to burn anything up. Okay, I'm all plugged in. Turn it on and see if anything lights up. I don't see any indication that this thing's drawing any power whatsoever, and that's not a good sign, as I would expect the tubes to start glowing and there'd be some type of a current draw. So, oh, this might be bad. This might be a bad transformer on this unit. Wait a minute. Oh, the filaments are heating up. I can see them starting to glow. Yeah, that one's definitely starting to glow. So we have some power through here. This is another one of these electromagnetic speakers. So the B plus is drawn through a coil on the speaker itself, which is used as the magnet. This is how old this is. It's a no permanent magnet on the speaker. I'm sure that light bulb is burned out. I hear no sound, so now we have to start troubleshooting and see whether we have any B plus and so forth. I see nothing lighting up on the current limiter bulb, which I should see something on that, because we are drawing current. Obviously, there's some heaters are starting to heat up. We'll just take a look and see whether there's any voltage anywhere on the circuitry here. So I'm just gonna put my meter on here. I'll ground one probe to the chassis. And then we'll look and see if we've got any B plus on the rectifier tube here. Actually, we'll see if we have any AC first of all. So AC voltage. Do we have any AC? 225 volts, so the transformer's working. So let's just look and see whether we have any DC. 2 volts. A little bit low. Should be a lot higher than that. Nothing on this side. Now it could be, it might be the electrolytic is shorted, but I seriously doubt that, because this thing should be drawing some power. We should be getting some voltage here. If it was, if the capacitor was shorted, for example, I would expect to see the current to go up and we'd see the light bulb light up. But we're not getting any DC at all on the rectifier. So the rectifier tube itself may be bad. To do a little bit more investigating to find out why we have no power, but we should have a DC voltage. If the rectifier tube is working, we should have a B plus voltage coming up here, and we have nothing. But as you can see, I've got the AC voltage going in. 242 volts on one side. Here's the other one. A little lower on this other side. Should be the same. That's the filament voltage. I got no DC whatsoever. Could be bad rectifier tube. I'd look through my old collection of old tubes and see if I've got one of these rectifier tubes. I might. I have a box of old tubes. This is a 5Y4. So I'll look and see if I've got a 5Y4. We'll try that. That tube could, you know, if there's no rectification, we're not going to get anything on the set. This one's heating up. It's getting warm. I can feel it. I don't feel any heat on the other tubes though. So we may have more than one problem on this. In fact, I'll take that one out and just see if we get any voltage. This one was sitting in the cabinet, as was this one, when I got the set. Almost like somebody had pulled the tubes and not plugged them back in. See, these are direct heated tubes, so it should come up right away. And I'm not getting anything. That's just the capacitor holding that charge. Looks like one of the wires from the transformer here had been soldered down to the chassis when I turned it on its side because it's not bolted in place. Looks like this wire broke off. That might be the ground wire for grounding the transformer. Because it looks like that wire at one point went up to the chassis like this and was soldered down on this thing. That might be the return. That would explain why I've got no high voltage. There's no return for it. So this is what's happened on here. The center tap it's come off. Somebody had soldered it down. When they changed this transformer, they only attached it with one bolt. The transformer shifted and it broke the return that they just soldered down to the chassis right here. This wire here was soldered down. It just stripped it, soldered it to the chassis, and that was considered a repair. What a joke. How I know that that's the case is because I can measure in ohms mode between the center tap and the two plates for the rectifier tube, and we've got continuity. We've got about 600 ohms per side from the center tap to one side and to the other over here. Considering I just have a crappy little soldering iron, I'm not going to try and solder it to the metal chassis because I don't have a very big iron to do it with. So I'm just going to put a ground wire in. I'll use a black wire and I'll ground it to the common point where the capacitor grounds, because that is grounded to the chassis right here. It's a ground wire that's attached right to the chassis and spot welded on. So I grounded here to this terminal and then over to the other side where the wire is, and we'll just attach it to the transformer and put some heat shrink tubing on it, of course, because it's the return for the B+, and hopefully that will get my B+ back. Okay, now let's see whether we get anything different happening now when I power this thing up. I guess I'll monitor the B+. See if we get any B+ now. So this is the B+ line. Let's apply power and see what happens. Oh yes, 185, 190 volts. I would say that the B+ is there. Let's see whether we get anything as far as noise on this thing now that the B+ is returned. Okay, power on. We'll see if this thing does anything. I don't see any filaments lighting up on this tube. So I think one of the doing a little testing here. I don't have any filaments on. The reason the tubes aren't warming up, this one is because it's a directly heated cathode for the filaments. For the rectifier tube, directly heated. These ones are indirectly heated, so they have a separate filament winding. I should have 6 volts across the tubes, and I'm just checking a few of the tubes here. I don't have any power, any voltage across the filaments. So I think there's another winding here on this transformer that is open. Because there should be a filament winding connected here, and I'm not seeing any voltage. Well, the reason we don't have 6 volts is because there's a second wire here. It was also soldered onto the chassis, and it's not. And that's that one there. And that's my return for my filament that is not connected. I gotta open that one up and connect that one to ground as well. See if I've got my meter on ground, because one side of the filaments is grounded. The other wire here, the green wire, is going to my filaments. This is the other side of it here, and if I bring the meter in so you guys can see it, and put my probe on here, AC settings. That's my filament voltage. Oops, so I'll hook another wire up to that. See if my tubes light up. I might actually get some sound out of this thing. Okay, now I got a connection. We'll just take this down and connect it at the same place as I did the other one. And if you're wondering why I'm not putting any heat shrink on this, it's just a ground. It's not going to hurt anything. It's not going to short out to anything. I guess it could, so maybe I should put some heat shrink tubing on there. Yeah, there's nothing for it to touch except for this wire, which is going to have high voltage on it. Oh well. We'll deal with that later. I want to see if this thing's going to work. Oh, we got a light here. That's a good sign. We have power. Now are the tubes all going to warm up? I hear something. I hear something. I hear a hum. The hum is good. That means that the amplifier is working. No. A hum just means it doesn't know the words. Don't hear any sound yet, but I hear a hum. Let's let this warm up for a bit. See if these tubes get warm. Because these ones, of course, you can't see them, but they'll still get warm. That one's getting warm. That one's getting warm. I don't feel any heat on this one yet. Okay, well, we're making progress. I should change that filter capacitor on the electrolytic over here. I should change those out. Let's see if we got B plus getting to the other tubes. Okay, I'm just going to give it a 400 hertz tone. See if we hear anything. Which we do, which means that the amplifier is passing a signal. So we're getting some output. Not a lot of output, but we're getting something. And that goes back into this tube, I believe, here. Yes. Signal comes off of here. And it goes through this cap and then into that tube. And then out from that tube it goes over to the audio output. So I'm just changing out the electrolytic cap on this unit. See if we can get rid of that hum and see if it makes any changes to the reception. The amplifier, as I know, is working, but we're not receiving any signals. So I'm trying to find a proper schematic for this. I have ones that are close, but not the exact schematic for this radio. So I'm going to try and find the right one, and we may have to come back on this and work on it another day if I can't get it going without a schematic. But we'll try a few more things. It's going to be, it could be a bad tube, right? It could be one of the tubes is bad, but I don't have my tester handy. I have to borrow that back from the guy that owns it. When I need to test a tube, I borrow a tube tester. I should get my own someday, but every time I look into tube testers at ham flea markets, they're asking outrageous prices. The last one I looked at, I think someone recognized me. The price went up to 500 bucks. It's like, no, I'm not paying 500 bucks for an old tube tester. This cap has been replaced. This wire is put the cap there, so we'll see if we get any noise on this thing now. Don't hear any hum. That's good. Got rid of the hum. Hear the volume control. The hum is gone. That's a good sign. I just don't have any reception. It might be this detector. This 6SQ7. This tube was sitting out of the radio when I got it, as was this one. So someone's been into here monkeying around with it. I was going through my box of tubes to see if I had any tubes. And I do have a couple of these tubes. I do have the 6SQ7, and I also have the 6SA7 oscillator. We got oscillator mixer. We have no noise whatsoever. I've got the 6SA7 tube in my hand. Let's just unplug this one, and we'll plug in this tube and see whether, and if that doesn't do it, we'll try that. I don't have the IF tube, unfortunately, but we'll see if it's a bad tube that is making this thing dead. Oh, I got sound. Sounds like that speaker's a bit bagged, doesn't it? It's working. It's working. Unbelievable. The speaker is in not too good a shape, is it? Let's just clip another speaker on there and see how it sounds with a different speaker. I'm pretty happy right now. Yep.
We're talking bedroom, living room, and kitchen just all wide open. No parking spots. O'Neill's gonna have a few clouds to give up. So Stan's gonna probably get a bike, and he's gonna probably be enjoying the bike lanes in Vancouver. That's great.
It's working. Love it.
Well,
There's my test transmitter. That speaker I've got on, it's probably not the right impedance for this thing, but as you can hear, the internal speaker is making lots of noise. But it's working. Hey. Incredible. This old radio just needed a couple caps, one new tube, and it's working. I wonder if this audio output tube is a little bit weak. I'm not getting a lot of volume out of it, but I'm getting volume. It could be the output tube is a bit weak. It doesn't seem like it's getting hot as it's supposed to, though, because the filaments aren't lighting up real bright. So this transformer obviously has been changed before. I don't know whether it's the right value or not, but definitely this speaker is not in good shape. And the way that this thing operates, it's got this coil on the back of the speaker here. It produces the magnetic field for the speaker. It's not a permanent magnet speaker. It's an electromagnet. It uses that coil as like a humbucking coil to cancel out hum. So the B plus runs through the coil. It's a good thing I got to talk over this, because this is just a radio station that I've got over my transmitter. So I probably get hit with copyright. I'll have to keep an eye on that I don't let that play for more than a few seconds. But as you can hear, it sounds a little better through another speaker. I'm going to put it on a talk channel.
it's got 2.5 acres where you can have the reindeer. The house itself is only a 1-bedroom, but it's stamped in his wife anyways, and they want to keep the elves on the, out on the acreage. And I mean, he can definitely land his play and you know, spend his summers in our area.
Okay, well, I've got this thing going. I'm pretty happy that I've actually got sound out of it tonight. Next video, I'll do another one on this. I'll call this one part 1. We got it going, got some sound out of it. I'm going to get my buddy to bring over his tube tester, and we'll go through and test the tubes and see whether this one's weak. I don't have another one of these audio outputs, so if it is weak, I'll have to order another one. I'll try and find one, but at least I know now that what I've got here, this project is working, because I got sound out of it, which is more than I had before. I guess if I touch the antenna a little bit louder too. Okay, I just disconnected the internal speaker that's noisy, so I'm running it just through an external speaker. So that's working. Again, in part 2, we're going to restring the dial string, as I don't have one, but I want to test the other tubes out and see whether we've got a weak tube. But before I do that, this dead tube, I'll show you guys what's inside one of these things. We'll open it up. It's a glass tube inside here, is what it should be. I do have 2 more spares for the 6 SQ7 as well. I have 2 spare tubes that I can put in here. They both work. They give me the same volume, so there's nothing wrong with this one. I don't know about that one. I'm sure that the IF tube is fine, because if the IF wasn't working, we wouldn't have any sound, just like when the mixer wasn't working. This one might be a bit weak. Sorry about my voice. I've been sick for the past couple weeks here. That's why I haven't been doing a lot of videos. After that experience of that kid coughing all over me about 3 weeks ago, I guess now, sure as hell I did get sick, and I've been sick for the past couple weeks. I have been posting stuff, but the stuff that I've been posting was stuff that I actually shot before, because I don't always post stuff the same day that I shoot it. I shoot a lot of stuff, but I don't get around to editing it for sometimes a week or two. So I haven't been shooting anything over the past almost 2 weeks now because I have been under the weather. Anyway, let's pull this old tube apart so you guys can see what's inside it. I've never opened up one of these tubes before. It can't be that difficult. Watch me stab myself trying to do this. I know, I'm buggering up this tube, but this tube is shot anyway, so it doesn't matter, because this tube is FUBAR. So there you have just your standard glass tube inside the case. There's the sealing off point there. They did this for these RF tubes so that the tubes themselves were properly shielded. This was pre-internal shielding. The later tubes actually had a screen around the inside that wrapped the plate so that the tube wouldn't radiate. But earlier tubes, they did it this way. And these are pretty rare these days to find one. That's when I saw this radio and it had these metal jacketed tubes in there. I had to have it just because they're rare. And as you can see, I've now got a radio that plays. Yeah, the built-in speaker is kind of toast. I guess I could refit a regular speaker on this thing. I don't need it to be a dynamic speaker, but I'd have to leave this coil in because this choke actually forms part of the rectifying circuit. So I'd have to leave this in anyway, but I'll have to find another speaker that I can put in the radio somewhere. Anyway, this is more for aesthetics than anything. As long as it works, I'm happy. It's working. It's not going real loud, but it's got good enough volume. Anyway, that's it for part number 1 on this radio. There will be a part 2 down the road, because I'm going to restring the dial string. I don't have a dial string to put on there, so I'm going to restring that, and we'll do some work on that. I think maybe I might refinish the cabinet, make it look nice, and finish it off. But I am definitely going to borrow my buddy's tube tester so we can test these tubes and see whether we have any other weak tubes, and if I do, I'll try and find one for it. So to cap off, before I put this thing together, before I put it back to complete part 1, we changed out that cap, that cap, that cap there, that cap, that one. That's the 5 of the paper caps, and then 3 electrolytics, 1, 2, and 3. Those are the capacitors that were changed, and of course this vacuum tube over here, the oscillator mixer. That's what's been done on this one to get this radio back functional. And as I say, the speaker itself is noisy, but I can't really do a lot about that. I have to try and find a replacement speaker. Good luck, right? Especially if I try to find an original one. But that's the least of my worries now. It's producing sound. My other really old Rogers Majestic that's older than this, the speaker on it is also shot. I think that just happens to, that just happens with these speakers with age. The actual, I think probably the glue that they used on the wire, on the voice coil, when they wound it to the paper cone, the glue has deteriorated and the voice coil is loose, and you can hear it. raspy sound. Speaker itself is toast, but can't do much about that other than try and find a speaker that I can replace it with. Anyway, that's it for part 1, and we'll catch you in part 2 when I get around to finishing it, which I'm going to do some work on the cabinet and clean it up a bit. It's in pretty rough shape. Stain it, varnish it, maybe just some varnish. Clean it up and varnish it. That'll probably make it look a little better. Anyway, thanks for watching. Hope you enjoyed looking at this old vintage General Electric radio. As I say, I'm positive this is the pre-war model. If not, it's very close. I would put this between about 39 and 45, I would guess. I can't find any data on it. What I did find is I found chassis that are a little more modern. Like this one here uses series strings, and it's dated October 25th, 1945. This one uses the 12SK7, 12SQ7, 12SA7 converter. So basically the 12 volt versions of the same tube as this one uses, but no transformer. And this one's dated 1945. So we know that this is earlier than that. So I'm going out on the limb figuring it's probably late 30s, early 40s. I think for sure it's going to be a pre-World War II radio. Anyway, definitely a collectible item, and it's working now. Thanks for watching. We'll catch you again in the next one real soon. Bye.